So I got this question morning, that is, so from the questionnaire, I think already we discussed this part, is how to connect to two devices, how to check whether one device is connected to another device. Okay, there's a already we know it, but just for your information thing, okay, just for a small clarification. And it is also, so next what we are the discussion is going on, that is also helpful. Okay, so point is, guys, for example, I have a PC or a laptop kind of stuff. So here I'm talking about a physically means that with a cable connectivity type. Okay, it's not a Wi-Fi related. A Wi-Fi also I will tell if you want, if it is required. Okay. So generally we don't connect the devices, means PCs directly, right? We can connect, but we don't connect. If you want to connect the like that, for example, you want to connect one PC to another PC or a PC to laptop or laptop to laptop, we can connect directly also. But that time we have to use something like a rollover, crossover cable. Okay. First point is, anyway, whatever the connection it is, first thing is the device must have a NIC, means a Ethernet card is there. Wide type of connectivity means Ethernet. The current one is gigabit Ethernet. Okay, we have a Ethernet on the system. Okay, so we have a Ethernet to connect. So how the Ethernet cable, like a backside of your PC. I want a PC related, and this is showing different now. So okay, we have this one. Imagine like this is a PC. Okay, if you go to this, there is a RJ45 connector. Normally, it is in the back side of the system. Even if you go for laptop, okay, back side of the system. Okay, and this is a switch. This is the PC. So in the back side, you can see there is a cable is going on. So in the back side, we see this RJ45 connector. Okay. And next one is what we need is switch. This is a switch. And if you double click open, you can see the zoom in. So this is the switch ports. From here to here, we should connect with a straight through cable from PC Ethernet port, Ethernet, fast Ethernet or a Giga Ethernet to the switch port. Okay, this is one connection, but we need to communicate between two devices, right? So then we need another system. Maybe if you have a laptop, this wired type of connectivities, right? So then we need a cable connecting to this. See, the laptop also I'm connecting with a wide type of connectivity. When if you go to the laptop, see there is a fast Ethernet port is there. Okay. So this is first is connectivity. Connect the devices to your switch port. Okay. So the here it is what it is. These things RJ45 sockets. It is also we use RJ45. So PC having a or laptop or PC having a Ethernet or a fast Ethernet. uh, Ethernet means that's a LAN card it is there. The port is RJ45 using a CAT cable. Okay, maybe a Cat6 cable is better. Gigabit support is there, 1 Gbps support is there, or Cat5e or Cat6 cable we are using. UTP cable from one end of the cable is going to PC, another end of the cable go to the switch. Okay, this is connecting the devices. Understand, guys? Connecting the devices.
Sir, without switch we can connect.
Without switch means
If we want to connect two devices without switch.
directly like
Yes,
this.
sir.
You can connect. Okay, here it is again, same NIC fast Ethernet or a gigabit Ethernet. You use it, RJ45 socket. RJ45 socket is there. Okay, so we can take a cable like a Cat6 or Cat5e cable. One end of the cable go to the PCA, another end of the cable go to the PCB. But two devices only we can able to connect like this. Okay, one to one, point to point type we can able to connect. And the cable type we can use straight cable or crossover cable. Because similar devices we use crossover cable. Of course, it's CAT cable only, normal UTP cable only. But the pin configuration is little different. This is better to use crossover cable, or you can use straight cable also. Just like how you use this cable, we can use it. But one-to-one communication. Second one is I have a devices, either can be PC, laptop, or mobile or thing, okay, with a wireless type of connectivities. The wireless, we don't require cables, but they need a NIC, right? Built-in NIC is there inside, or maybe USB based NIC, or maybe insert a NIC into your desktop kind of stuff. Okay, and here it is. We can have to configure this Wi-Fi router or access point. SSID means Wi-Fi name, and there is a password, right? If you click on the device and search for the Wi-Fi network names, and it will display the different Wi-Fi network names. Click on the name and give the password, and the request go to the router and verify the name and password. Okay, it is good. Then it will give the connectivities. Once it is given the connectivity, and of course, if you have a DHCP, you can get an IP address. Okay.
Okay, sir.
Yes, in this one, we given a connectivity. The first step is completed, but how they will communicate each other, how they can able to communicate based on what we are communicating. So you use IP address, right? And this IP address, either you should go and configure, or you can use a DHCP server. In our home, we have Wi-Fi router. So the Wi-Fi router is act like a DHCP server. Okay. So you have a DHCP server connected to this switch. Okay. This DHCP server give IP address to this client PCs. Either you configure manually, go to the desktop, see. Either you configure manually or you should use a DHCP server. I'm using a server here just for our understanding, separate server we are using. And that is also I'm connecting to this. First of all, I have to configure a DHCP server. Service is on. And starting IP address, I am assigning 192.168 1.100. And the subnet mask, of course, it's a class C. And the gateway is 192.168.1.1. And DNS server also say, I will separately, I will tell 192.168.1.53 is my server. I just add that pool. The pool number is 1. Okay, remove the pool 0. We cannot remove. Okay, we can use the pool 1 on off. On. Okay, so this is my DHCP server. We'll see. What is my IP address? I didn't get any IP address. Why? Because I have to tell get IP address from DHCP, automatic configuration. So what happened? This client PC, when I said DHCP, so it will send a request to the DHCP. So first of all, it will try to find a IP address from DHCP. Still, it is got an error because I know 169. I should get a 192. It got 19. So maybe there is a problem here. DHCP service is on. This one we have to remove this. This one is save. Okay. Can't we remove this one? Ethernet. So clear CLS, nothing works.
Sir, is it necessary to use a submask which is default for particular class?
Yeah, if you don't specify the subnet mask, okay, it does not understand what part is network part and which part is uh, host part, network ID kind of stuff.
Sir, only those device contains NIC in which are only networking device.
Which one?
I'm saying, sir, only those device contain NIC which are only networking device.
Yes, those devices have sometimes most of the devices having built-in NIC, wired or wireless type. So in case if device means, for example, you have a older desktop, it is there, it does not have NIC inside, so you have to attach. Without NIC, we cannot communicate.
No, sir, I'm saying that only networking devices contains NIC chip
Yes,
or
networking
others.
device means a device like if you have take a printer. Generally, printer don't have NIC. We have to connect with a USB, some kind of printers. But network printers having NIC. Network printers are there. It means we can connect directly to the thing. That's why I use the word device instead of computer or a laptop or a system. Why? Because of certain devices can connect it to network with the help of NIC. They have NIC, of course.
Sir, as you told earlier that every class has their default subnet mask.
Yes.
So if I use a subnet mask which is not for class A, then it will not work.
This if you change the subnet mask, like you have a class B IP address, but you change the IP subnet mask to the not this. You change the subnet mask, okay? Like you given a class C type of subnet mask to it, so then maybe it will work. But as I said now, IP address, subnet mask. If you don't use default, if you use customize, based on that, your network is changed. Still, it is getting APIPA. Why my from my DNS from this? Why it is not able to? Yeah, that's the point. This system don't have an IP address. Sorry. So that's the point. This system do not have an IP address.
Sir,
Yeah, tell me.
when you was assigning IP, like it was starting from 169 maybe, uh, class B. Why it is happening?
Very good. That's a good, very good question. Very good observation also. So when I'm trying to get an IP address from DHCP, I'm getting 169.254, right? So actually my IP address configuration is, actually what I thought my IP address configuration is 192, right? This is what I said. From here, give IP address from 192 series. And suppose this system should get an IP address from 192 series. It is got 192 series. But this one, we got a 169. Now it is got it. Now it is got it. If you see, look at here. And now it is got a 192 series. But earlier it is not like that. It is shows like this. Okay, that's what I didn't explain earlier. But if you are observed, that is now you will understand much better. Okay, guys, this is a PC try to get an IP address from DHCP server. And because of some my configuration, means the network configuration, I done mistake. So what happened? It tried to get an IP address from DHCP server, but it is failed. My system, this system is failed to get an IP address from DHCP server. Failed. So what this system will do it? What this system will do it? It will assign itself an IP address from this series 169.254 dot something dot something. Okay, this something dot something, because based on the PC's MAC address, it will add these two things. But these are constant. Okay, so this IP address we call it as a APIPA, automatic private IP address. Automatic private IP address. What is this APIPA address? When a device is failed to get an IP address from DHCP server, it assign an IP address to itself. It will assign an IP address to the NIC itself. Means my PC assign an IP address to that NIC an address from 169.254 series. Based on its MAC address of NIC, it will assign. Okay. So why it is we got 169.254? This PC earlier it is failed to get an IP address from this DHCP server. Now this DHCP working. So I got an IP address 192.168.1.100. If you see here, it is it's not showing here. It is also changed 192.168.1.102, and this is 101. See IP address, subnet mask, default gateway, DNS server address. First check IP config. So I can see IP address, subnet mask, default gateway. I use /r. So then I will know the MAC address of this PC, IP address, subnet mask, default gateway, DHCP, server address, and the DNS server address. So who is my DHCP server? 192.168.1.67 is my DHCP server. And what is the default gateway is 192.168.1.1. Okay, guys, understand DHCP 169.192. That's if how it is configured.
Yes, sir.
Okay. Now DHCP is working. Issue is automatically resolved. If issue is not automatically resolved, you have to enable, disable, or connecting, disconnecting, or use the IP config, release IP config kind of stuff. So I will show you that command also. Here it is, IP config. What it will display? It display the IP address. Okay. In case you are getting 169, or maybe if this IP is struck, IP config, it got an IP address clearly. We don't require to use this command, but in case you got a 169.254, that means you failed to get an IP address from DHCP server. Now DHCP server is restored. Still you are getting 169.254. Or maybe you are disconnected from this network and connected to another network, but your IP address is not changing. Even it is automatically assigned, but IP address is not changing. You change the network, but IP address is not changing. In those two conditions, we are going to do this IP config space / release. It means it remove the configured IP address, and renew means it will get a new IP address from DHCP server. Try to get a new IP address from DHCP server like this. Okay, so this is how to connect. First question is how to connect a net. Two devices. You can connect two devices directly. Okay, like you take a one device and take another device and use a crossover cable and connect one NIC to another PC. Like this, you can able to connect. This is only one-to-one connectivity, but this is many devices we are connecting. The actual we use like this connect. Many devices we are used to connect with a switch. And if in case you have a Wi-Fi router, inside a Wi-Fi router you have a built-in DHCP feature, so that will give IP address to the devices. Or you have to use a DHCP server to assign an IP address to devices. Or you can configure IP address manually also. Okay, you can configure IP addresses manually also. Okay. This is connectivity. The next one is test, make sure that both devices are communicating or not. Check this IP address of this device is IP config. What is the IP address? 192.168.100. And this PC IP address 101. 192.168.1.1. Okay. From here, I'm going to try connectivity. Ping 1 here 192.168.1.101. Okay, this is PC0. IP address is 1.100. And I'm trying to communicate it to this PC 101. I'm getting reply from 101, means from my destination, I'm getting reply from 101. Okay, and I'm getting ping successful, 0 packet loss, sent 4, received 4, 0 packet loss. And here also it is showing reply from the destination IP. Meaning is both side connectivity is good. So you have to test from here also. From this is PC1. IP address is 1 from here to there. 192.168.1.100. See, both side connectivity is good. Okay, this is the test connectivity between the devices. Okay, first connectivity, next IP address. Either you configured manually or you should get IP address automatically from DHCP, sir. Okay, next one is make sure both systems are communicating or not. With the help of ping command, we can able to test the connectivity. Guys, understand up to here?
Yes, sir.
Okay. So it is not a disconnected topic, guys. Actually, it is a kind of connected topic only. That's why I'm continuing. Okay. And already we discussed that one. So we are going to discuss the next part is servers and services. Okay. This is again small bits and pieces part are there. So why we need to connect the devices? Why we need to connect the devices? That is an important factor, right? Why we need a connectivity? Okay. So why we need a connectivity? Okay. To communicate between the devices. As we discussed, guys, we have a devices and these devices are connected. So what type of connectivity it is? We are connecting. I have a laptop. I have this laptop. I can do some programming. Like I have a inside, I have something like a Visual Studio. With the help of Visual Studio and Python, I can do Python programming. For that one, I need to connect it to any devices, right? I am having some MS Office here. I can do things. I have a paintbrush. I can paint. For this one, I don't require any connectivity, right? But why we need a connectivity? To share, to communicate, to share the information, or to communicate between the devices for sharing of information or sharing of resources. You want to send a mail, or you want to send you want to share a printer, or maybe an instant message you have to send it, or maybe you want to access a web page like that. Okay, so what is the importance of connectivity? To share the information or to share the resources. First point. And these are all in individual pieces, guys. These are all in individual pieces are connected to the network, and they have their own IP address, and they can able to communicate each other. They can able to communicate each other. They can able to share information between them. For example, A PC having some data. I shared this folder. So from BPC can able to access this folder. So then BPC got this information or a document in A can able to access from B. Data is in A, but we can able to access from B. We can able to access from C. So why? Because of their devices are connected in network. So then we can able to connect and then communicate by sharing information or a resources. This DPC is connected to a printer using something like
Sir,
a
can you
USB.
explain again?
Yeah, I will do it. Okay. APC, for example, APC contains a folder, a shared one. I want to access it. I like to access that information. See, for example, there is a system, a shared a folder. So that contains some information, some documents are there. From other PCs required to access. Of course, they have some username, password kind of stuff is there. Okay, so if username, password is shared, so you can able to access. See, I access this folder data from network like that. Of course, it's a locally one only, but I can able to open, I can able to read that data content. Okay, so A is shared information, B can able to access that information. Okay, but there is no centralized control. Only A should give a permission to B to access. That's it. Okay, or C knows A username and password, so they can able to access. Nothing but nothing is centralized here. So only thing is, so they can able to share information, or they can able to share resources also. Like here I have a printer. D shared a printer to the network. So this is actually USB connected printer, but from it is connected to D. D shared the printer. So if anybody want to take a printout, so they can go to the D through the network and they can be able to take a printout. Shared printer it is. Okay. So we can able to share information or resources between the devices, so that's why we are connected it. Okay. Without centralization. So we are not using any servers here, or we are not using any specific centralized authentication system here. Here, every device act like their own, act like a server in the particular instance of time. For example, A providing information, B accessing information. So when B is accessing, that time A is like a server, B is like a client in that particular instance of time, not always. Okay, so this type of network we call it as a peer-to-peer. Peer-to-peer. What is a peer-to-peer? It is a kind of work group model. I will explain what is work group model, don't worry. for sharing of information, data, or resources between two or more systems without centralization. There is no centralized control here to share the data between the devices. Like they can able to share, they cannot able to share. So they will decide in the system. So there is no separate controller for that one. A system act like a server and other act like a client in a particular instance of time. For example, D provide a printer sharing. A access the printer, shared printer. From A, I'm accessing shared printer, which is shared from the D. So A is accessing means A is a client and D is a server. In the particular instance, not every time. D is not a printer server, A is not a data sharing or a file server kind of stuff. It is not like that. Okay, there is no centralized control, no specific server client model it is. It is in that particular instance only it will work. Okay, all are individual pieces, no centralized control. It is a decentralization kind of stuff. Understand, guys? Peer to peer.
Yes, sir.
So we'll go to the server and client, so then we will understand better. Same thing. There is a server. Maybe it is a web server, or maybe a file server, or maybe it is a printer server, or maybe an authentication server. Okay. The client's devices will access the service from the server. For A PC, it is a server. For B PC, it is a server kind of stuff. Okay. A, B, C, D. And there is a centralization. So this server, based on what type of server it is. So A will give, for example, it is a web server. It is always a web server now. It can be a client for some other services, but main important is it is a web server. It provides a web pages to the client pieces. A want to access the website, contact. So there is a centralization means the services are located in one point, people can able to access from it. Okay, it is a server and client. Exactly say, guys, client access the services from the server and server provides services. Here is a two lines. Okay, so compulsory understand these two lines, guys. It is always important to remember. Server provide a service, client access the service. Server provide a service, client access the service. Okay. Service always provide a service. It can be a mail service or web service or authentication service or file related service or printer related services. So it provides a service. So client will can able to service. For example, a web server provide web pages as a web service. Client from the browser, we can able to access the web pages from the web server. You're accessing a web page from web server, and web server is providing web services. So we can able to access web page. This is a statement, right? What is the last statement? That is what is the statement I have written here? So read it carefully, guys. Server never provide to anything to anyone until unless a client asks for it. Client has to ask. Client has to send a request to the server. Client request a service or a specific service, the service to the server. I have to ask a web service to from the web server. I'm sending a request to the web server. I want a web page. I have to send a request to the mail server. I want to send a mail or I want to retrieve my mails. I want to send a request to the FTP server. Either I want to upload a file or download a file. Okay. So client request to the server and the server send response to the client. Okay. Understand, guys? Client send request to the server and server give response. First request and response and then response. Okay. Server understand what is the client request. Server understand what is the client request by the protocol. Client send HTTP request means the client is asking a web page. Client send FTP request. Client want a file upload or a download kind of request. Client send a SMTP request. So client is actually asking for sending a mail. Client send a POP3 request. It means the client want to retrieve the mail box content. Okay. So client send NTP request to the time server. The time server understand and it will give the response, configure the time to it. Okay. Guys, understand up to here? I told 3-4 points about a server and client.
Yes, sir.
Right. Servers send a client to servers understand client request by the protocols. Okay. What is this server? Why we calling it as a specific server? I should call a server, right? Why I'm talking in a specific server manner. So based on what service it is providing. I call it is a web server because of it is providing web pages, web related service. I call something as a mail server because of it is providing mail services. I call a NTP server, time server, because it is providing time related services. I call something as authentication server, deployment server, print server, based on what it service it is providing. Okay. All are point wise only, guys. How a server become a butler server? I have a machine. Okay, I have a machine. I have some computer is there, or maybe a server, a data center is there. Okay, maybe I have a multiple blade servers are there, tower servers are there. I have a hardware. I installed a server operating system in it. I have installed a server operating system. And that's it. It is a server only. But how it is become a butler server? By installing a server related applications, by installing some applications or a packages, or there is a built-in features or a roles. If you configure those things, install it and configure it, so then it is become a specific server. By installing and configuring a built-in features or a roles or an application, by installing and configuring applications or packages, then server become a specific type of server. For example, I have a Linux machine is there. Then I install NGINX in it. It's a package, a simple application. I install NGINX and configure it. Then it is become a web server. I install HTTPD, Apache HTTPD and configure it. Then it is become a web server. I install Tomcat, it is become web server. I go to the Windows server and I configure this IIS, Internet Information Service, it is become a web server. Okay. So I have taken a Windows server and I installed Exchange application, Microsoft Exchange application. Then it is become a mail server. I've taken a Linux server operating system. I installed a Zimbra application. Then it is, and I configured it. So then it is become mail server. Mail server. I take a Linux machine. I installed voice ticket application inside. Then it is become a the ticketing related server, voice ticketing server. Okay. So how a server become a particular server? By installing and configuring the built-in features, or by installing some applications and configuring it, or maybe I install the packages, application or packages, you can say, and the related packages you install and configuring it, it become a specific server. Okay. Understand, guys, how a server become a specific type of server and why we are calling that specific type of server it is. You are getting a IP address services from DHCP. So you are getting configured with IP address, right? You are configured with IP address from DHCP server. So from where you are getting that service? From DHCP server. How it is able to provide? So you have taken a machine, installed built-in feature, or by installing and configuring some packages inside. So obviously it is become DHCP server. Even you have taken a router and inside DHCP feature, you enabled it and you configured it and you can able to get it. Okay. Can we go next?
Yes, sir.
Server based on the services. Web servers. Already I told the application and protocol. This is the protocols. These are the applications. So based on that, this is a system become a web server. File server, DHCP server, DNS server, domain controllers means authentication servers. Windows deployment servers means you can able to install a operating system into multiple devices through the network. Mail servers, VPN servers, storage servers, database servers, virtualization servers. Okay. So I listed only some of the servers kind of stuff. So like that. Okay. You take a machine and you configure that as a web server. So we can able to access the web server using HTTP or HTTPS protocol. File server by installing or configuring built-in FTP or VSFTP or SFTP kind of stuff. So then it is a file server. DHCP server provide an IP address to the client PCs. Actually, DHCP server configure an IP address to the client PCs. Okay. Okay. So how it is? So by configuring FTP server as a DHCP server. DNS server, domain controllers means authentication servers. WDS server, deployment servers are there, mail servers, VPN servers, storage servers, database server. Like you take a machine, okay, and you install an operating system. In that one, you install Oracle DB application, or maybe MySQL application or MS SQL application. You install it, and it is become a database server. Virtualization servers, different virtualization servers are there. You take a machine and directly install a hypervisor software on it. So it is become a virtualization server. MS, Hyper-V, Microsoft Hyper-V, or a VMware vSphere or Citrix Xen server or Proximox or Red Hat Enterprise Virtualization. Hypervisors, you install in a one server hardware and it is become a specific server, so where you can able to create and run virtual machines inside. Okay, these are the different servers based on what service it is providing. Okay, these are the different servers based on what service it is providing. And next one is different servers. We call something as a server based on what operating system it is installed. We're calling a machine as a server based on what service it is providing. In another words, in other way, another thing is, so based on what operating system is installed inside. Okay, already I told desktop operating system is different, server operating system is different kind of stuff. Desktop operating system is user end related. We can able to play games, programming, audio, video, multimedia kind of stuff. Okay, so we can use different applications. We can connect it to internet, and we are accessing lot of things, right? We are also become a client device, so we can able to access the things from the servers. And coming to the server OSs, different server OS operating system, by installing a server operating system into a device, then we call that one as a server based on what OS inside. Okay, from in a Microsoft, as I know from Windows, NT server is there, 2000, 2003, 2008, 2008 R2, 2012, 2012 R2, 2016, 2019, 2022. These are the different Windows Server versions are released. In Linux also, Linux-based servers also released into the market. Red Hat Enterprise Linux, CentOS, Fedora, Debian, and so many other Linux-based, Unix-based servers also there, including IBM operating systems are there. So that is server. Okay. Okay. And of course, I said a hypervisor kind of stuff. If that is a kind of a voice type only, just we install in a physical hardware, then it is a virtualization. Okay, so based on the server OS, that is, but we call something as a server, whether it is with a specific OS or specific service it is. Okay, so we call something as a server. So why we are calling this one as a laptop, or why we call this something as a desktop? So it is user end, and desktop means we are placing on the desk. We are laptop is for a lap purpose. So it does not mean it is a desktop related only. Both are user end devices, and we use these devices morning to evening kind of stuff, right? Maximum 12 hours, 16 hours we can able to use it. The server has to be run because one single server has to give a service to the multiple number of devices. Means if I want to open a document from my PC, I have to go to my PC, I open the document. But same thing if I access from different devices, like a one web server will provide a web pages to multiple systems, right? So in that case is what happen? Okay, so that server hardware must be powerful. So they use a separate processor types like Xenon processors. They use it, and not
Sir,
only
server
one,
is nothing, just a list of CPUs.
not list of CPUs. Exactly, the hardware is little different. Means the stronger hardware than normal desktops. Costly it is. It is
But
like
still, it is a computer, sir. Still, it is a computer.
yes, still it is a computer, server or a desktop. Both are having processor, both are having RAM, both are having motherboard, both are having a storage like a hard disk or SSD kind of stuff. Okay, good. Both are a computers.
Just like we when we run application on our local host, they provide a global host. for all of
Yes,
us.
right. I'm using a MySQL in my PC. That is the local I'm running for my purpose. But same MySQL, if I run in a server, multiple users can able to access same application through the network centrally. That is a one good example. Here also, for example, this is a database server. Okay. So if I install a database in this PC, I can able to access. But if I install a database application here in the server, multiple devices can able to access that one. But to do that one, we need a stronger kind of stuff. It means a server having a multiple processors. Okay, not only one. There is a possibility of adding a more CPUs, more RAM slots, because more RAM physical memory requirement is there, and hard disks, number of hard disks we can able to connect it. Okay, so using a SCSI type of storages, SCSI like a centralized storage, SCSI type of storages with a high storage capacity related, RAID implementation, NIC teaming kind of stuff means it we can able to connect multiple NICs, so and we can make them as a team. So then one NIC is fail, another NIC is able to access. Okay, so that is how the server hardware is there. Okay, the server hardware is it is also a computer. Server is a computer, desktop is also a computer. But thing is, desktop will access the service and it runs some applications for itself, its own purpose in that system only. And it won't provide any service to anybody, right? But server is centralized one, and lot of clients will access the service from one system only. So then the hardware must be different. Okay. So the way other hardware means there is a CPUs, but not one. Multiple CPU sockets can be there. Multiple RAM slots, storage related, it's higher. And these servers also we have available in different shapes, like a tower servers. Tower servers are generally is like a desktop model only, but it is high towers. It's a bigger than normal server it is. This tower servers having a okay. See, this is a tower server. Yeah. You can see there is a storage kind of stuff. SCSI storages. You can remove this one and insert a hard disk inside. Okay, it is a tower server and it contains the processors. Everything is like this. It's not given any specific hardware information, so it's a very low price. This is better. Tower server computer that arranged in a rack or a cabinet provide foundation of communication between all devices within your data environment. How tower server works? Tower server rack server differences are given, but I need to show you how the tower server is look like. No problem. We'll go to the images. So we can see these are the different tower server. Guys, it is contains again same motherboard, processors, RAMs, storage, SCSI related storages also. Okay. So that is a tower server. This is a rack server. This is a rack server. Okay. So this guy is inserting a blade. So this is the blade server. So it is small blade which he can able to fit inside of this one. See, this is a one rack and we can able to insert multiple blades inside. This is also a blade server. These each individuals are a servers. This is 16 blades in one single big rack. Okay. So what about a rack server? This is a rack server, guys. This is also one single server contains storages as well as CPU, RAM, and SSD for storing OS kind of stuff. Okay, this is a rack server. Is look like this one. Blade servers are look like this one. Tower servers are look like no towers are there. This is the rack server and this is the blade server. This is a data center. See, it is data centers. What is the data center? It is the data center contains different set of servers. It may have a blade server, rack server, or tower servers, storage. What is the purpose? It runs different applications. The room which we are put it here is called a data center room or a server room. Okay. This is rear view, front view kind of stuff. Okay. So this is different servers. What is a data center? A data center means it contains servers, storage devices to store information or to store the data, networking, connecting these servers and storage devices to the LAN or to the WAN connectivities. Software runs in the server. The software which runs in the server, like it can be software running means it's like a different applications are running inside, like a web related applications like that. Okay. Servers, networking, storages, applications. This is our data center. And we should provide a cooling system and the power supply. And you can see this is a small example of a data center. If you see closely, guys, this is having so many types of servers with running of different applications. These five systems are a Dell-based servers, rack servers only, and running a OpenStack application. And this is PoE switch, power over Ethernet switch, IP phone related switch it is there. And it is a storage related, right? Six storage related NAS box, fiber optical channel SAN, okay? And it is there is a blades to two rack servers with virtualization server inside, and this is a uh, vCenter server from VMware. vCenter server application is running here, and this is running with VMware ESXi. Okay, and this is a fiber channel SAN switches, and again these are the OpenStack. So they created their own private cloud. That's what it is showing like this. Okay. So what is a data center means? It's combination of different servers and connection of servers to different types of networking devices like a switches, routers, fiber optical cables, UTP, STP cables, firewalls, storage devices like a SCSI, SAS type of devices, NAS and SAN, centralized storages, okay, RAID storages kind of stuff. And purpose is to run different types of applications. It can be a cloud related application, web server related web applications, like different services related applications are running. Okay, so that is the main point of server. And if you have a server, if you have a computer or a laptop, you need to provide a cooling system. But this is are required a more cooling system. Power supplies also required. And there is a profile called a data center monitoring profile. Related things are there. NOC engineers, data center monitoring profiles are there. So that is also good. Like you have a lot of servers in your organization, either one site or multiple sites, the data centers are there. So you can able to monitor entire your data center centrally. Already, I think I showed Op Manager. That is the main purpose of this Op Manager monitoring tools purpose is to monitor your data centers. How the servers are running, their statuses, load on the server, CPU, RAM performance of a server, disk performance of a server. It is. Okay. Guys, up to here. Okay. What is a server? What is a client? What server is doing? Okay, what client is doing, how a server become a specific type of server, and how we call a server as a specific server, and server operating system, different hardware shapes, okay, and what is the data center, basically. Up to here, understand, guys? Anybody, any changes? Neeraj came late. Anything? Final words? What about others, guys? See, look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And it should have shown 15, right? 14 plus 1, because I'm also one person, 15 has to show. And I'm telling guys, tomorrow it's a very senior, he's a IT manager, worked as a IT manager in a different organizations. Is luckily we are having the person is going to take the class tomorrow, is going to explain about ITIL, which is how the IT industry function based on the ITL function oriented, process oriented kind of stuff related to the IT industry. That is very, very important. That is helps our works much easier and how the IT organizations is there. He is going to be explain that one. That is first thing. Next, you guys also having doubts, which is I cannot able to maybe I can able to give a clarify, but is worked real time. I can able to explain what is WAN, what is LAN, what is router, how it is connected. But he's built in a real time. He built this router connectivity from one side to another side, how the public network, how private networks are connected. Okay. So he real time. So just morning itself, I'm talking to him only, right? So So he's going to be take care for tomorrow class because I'm taking his class for a troubleshooting point, some few things. So I'm taking care of his batch tomorrow. So tomorrow he's going to take. So make sure that everybody be on time. Don't leave. Don't join like at 12 o'clock. I will join kind of stuff. Don't do like that. So be there at 10:15 or 10:30 when he's said when is the class. Okay. We join. Mostly it is between 10 and 10:30 only. Okay, 10 and 10:30 only, between that one only. So be ready by 10 o'clock. And when I said and I share the link, join to his link only. Or maybe same link or he will share the link. So whatever the link it is, so join to that link only. Okay. And he's going to explain about ITL and as well as request him to explain this the network configurations in the real time, how this are connected. Okay. So you have a doubt. So ask him doubts, guys. He's very patient and he will explain everything step by step. He will explain. Okay. So only thing is you have to communicate him. He will ask, you have to tell answer. You speak to him. Like just from last few days, like 3, 4 days, you're asking questions, right? Don't ask about when is your interview, what is the HCL kind of stuff. Ask him technical, okay? So technical, or maybe if you ask any personal solution like so can I learn this cyber security, or maybe cloud related, or maybe like that also you can ask in the end of the class or start of the class also. Okay, not in middle anyway. So based on the topic, ask him. Based on your personal requirements, ask him when it is a personal attack it is. Okay. So very important guys. When I said class at 10:15, so maybe 5 minutes, 10 minutes is okay, but make sure that everybody join in that time only. Some are join at 10:30, some are join at 12:30. Okay. It's not a free classroom, right? We are not in this kind of classroom culture kind of stuff, right? So like whenever you want to join into the class, come and sit and listen. That is okay. That is that's a modern type of classrooms. It's not like that. We are providing class. Listen, that too. For me, it is maybe I will tell and leave, but he will get serious because he's just very senior. He's a very old guy also. Okay. So utilize this time. Okay, take a break. Be back at 12:10 because I already have taken another 5 minutes. Okay, come back at 12:10, 15 minutes. Okay, 12:10, 12:10. So it's totally 15 minutes break. Go and come back faster and have some tea or coffee. I'm going to stop recording. Okay.